Hello everyone, my name is Ayush Iyer and welcome to my channel. Today we will be learning about numbers. The reason we are learning about numbers is that numbers plays an important role in our day-to-day life. We use number in every place, every situation in our life, and the reason number systems was developed was because in order to understand the working of computer and how computer stores, manipulates and retrieves data, numbers play a vital role. So let us start learning about number systems. Now number systems are of four types: decimal number system, then binary number system, then octal number system, and the last is hexadecimal number system. These are the four different types of number systems developed and are frequently used in day-to-day lives and in various other purposes like for electronics and computer purposes. So decimal number system is a common number system that we use in our day-to-day life. This is the regular number system we have learned from our school. Binary number system is the type of number system that is used by computers and electronic products. They commonly include 0 and 1. Octal number system is another type of number system. Octal and hexadecimal are completely different part. So let us now try to understand all these four different types of number systems in detail. Now let us learn about decimal number system. Now what is decimal number system? A decimal number system consists of numbers from 0 to 9. Now there's a catch here that 10 is not included in this 0 to 9 because we can represent 1 and 0 as a combination of these decimal numbers, because 1 and 0 both are included within 0 to 9. So 10 is not included in decimal number system, means it's included in decimal number system but as a combination of decimal number system. So to summarize, we can say that a decimal number system consists of 10 numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are the 10 numbers in the decimal number system. Now how will we identify that a number is whether it is decimal, hexadecimal, binary or octal? For that purpose we use a concept called base. Now a base is nothing but the radix or the number of total numbers present in any number system. Now in the case of decimal number system, there are total 10 numbers. We can count it 0, 1, 2, 3 like this. There are total 10 numbers. So a base of decimal number system is 10. So any number, like for example 2 is written in bracket and a 10 is added as a subscript here. Now this is nothing but a base. Now it is important to note here that the largest number of a decimal number system is 9 and the smallest is 0. Now let us see how we can represent any decimal number in its power format or in any weighted format. Now for this we need to understand weights. Now what is weight? Weight is nothing but the corresponding value of the decimal number. Now for example, let us take a decimal number 56. Now 56 is a decimal number. Now how we can represent it in the powers of 10? Now why 10? Because we are talking about decimal number system. So we can represent this as 5. Let us write to the digits separately. So here we can represent this as 10 to the power 0 into 6 plus 10 to the power 1 into 5. Now as there are only two digits, so we will take 0, 1. Now if we just calculate the value, 10 raised to power is 10, so 10 into 5 is 50 and 10 raised to 0 is nothing but 1. So we can write 1 into 6 is 6, so the final answer is 56. So this is how a decimal number is represented in the power of 10. Now for this, it is important to note that we have to take the consecutive numbers or the consecutive real numbers as the powers of 10. So 0, 1, and if there are more digits, we can take 2, 3, 4, 5, 6, and so on. Now let us take an example of 224. Okay, so let us just simply write it in the powers of 10, like 4 into 10 raised to 0 plus 2 into 10 raised to 1 plus 2 into 10 raised to 2. You can see that first it was 0, 1, 2, and if there are more digits, we can add 3, 4, 5, like I said earlier. So 10 raised to 2 is nothing but 100 into 2 plus 2 into 10 plus, like I said earlier, 10 raised to 0 is nothing but 1. So you can write 4 into 1. So now simply let us solve this. So first multiplication 200 plus 20 plus 4. Okay, so if we simply add it, we get 224. So I hope you understand how we can represent any decimal number in the form of the powers of 10. So now let us go to the second number system, which is the binary number system. Now, what is binary number system? Now, binary number system is one of the most important number system because a computer or any electronic device only understands binary number system, which is also called as the machine level language. So what is binary number system? It is very simple. A binary number system consists only of two numbers, that is 0 and 1. 0 and 1. So a combination of 0, 1, 0, 1, any combination, not necessarily alternative combination like 0, 1, 0, 1, any combination of zeros and ones is called a binary number. Like for example, 0, 1, 1, 0, 1, 1, 0, 1, 0 is a binary number. Now, like I said earlier, base plays a very important role in determining the number system. So in this case, the base is nothing but 2. Now why it's 2? A base tells the numbers a number system can have. A possible number system, any number system has how many total number of values present in it. Like in this case, binary number system has 0 and 1, only two numbers. So we can write the base in this case is 2. So this is a binary number system. Now, the largest number in the case of binary number system, it's pretty obvious that it is 1, and the smallest is nothing but 0. So like in the case of decimal number system, here also we can represent the binary number system in the powers of 2 because the base is 2. So now let us take a simple example for our understanding. Our first example, 0, 1, 0, 0, 1, 0. Okay, so this is a binary number definitely because there are only two possible there are only two numbers, that is 0 and 1, which are the possible numbers in the binary number system. Now, how we will represent this in the form of binary number system, in the form of the powers of 2. Now, here let us write it separately as 0, 1, 0, 0, 1, 0. Okay, now we can simply write this as 0 into 2 raised to power 0 plus 1 into 2 raised to power 1 plus 0 into 2 raised to power 2 plus 1 into 2 raised to power 3 plus 0 into 2 raised to power 4. Let's check 0, 1, 0. Oh, I missed the number. It's plus 0 into 2 raised to power 3 plus 1 into 2 raised to power 4 plus 0 to 2 raised to power 5. Okay, I suppose this is too long, but commonly in exams they don't ask so long, they simply ask small numbers like 1, 0, 1, 0. Now this is an trick, not a trick, this is a method to convert any binary number to a decimal number. Now how that is done, let us see. Now we know that, as I said earlier, any 10 raised to power 0 is 1. So it is we all have learned in our childhood that anything raised to 0 is nothing but 1. So we can simply write 0 into 1 plus 2 raised to 1 is 2. So 1 into 2 plus 0 into 2 raised to 2 is 4 plus 0 into 2 raised to 3 is 8 plus 1 into 2 raised to 4 is 16 plus 0 into 2 raised to 5 is 32. Now when we simply add this, we get, now before adding, let's see, 0 into 1 is nothing but 0 plus 2 into 1 is 2, 4 into 0 is 4, sorry not 4, 0, 0 into 8 is again 0, 16 into 1 is 16 and 32 is into 0, so we get 0. So let's not write that. 16 plus 2 is nothing but 18. Now let's cross check, it's 0. Let's write it out. Plus 16, 0, 0, 2. Yeah, so 18. Now this is nothing but the decimal number, sorry not the 2, decimal number 18. So this is how you can represent any binary number in the form of power of 2, and this will indeed convert the binary number into a decimal number. So this was about binary number system. Now let's go to the third number system, which is the octal number system. Now let us learn about the octal number system. What is octal number system? Octal number system consists of 8 numbers total, which starts from 0 and ends at 7. Now remember that when I said there are total 8 numbers, total numbers are 8, it doesn't mean that it end at 8. Now because why doesn't it end at 8? Because we are not starting from 1. If we start from 1, then it would definitely end at 8. But we are starting from 0. So always remember that any number system starts from 0. So if I say total number system, total numbers in decimal number system is 10, then it doesn't mean that it would end at 10. Always subtract 1, you get 9. So total is from 0 to 9. Similarly, in this case as well, octal number system starts from 0 and ends at 7. Okay, so there are total 8 numbers. You can count it 0, 1, 2, 3, 4, 5, 6, 7. So there are total 8. So the base in this case, pretty obvious, it is nothing but 8. As I said earlier, the total numbers in the number system is 8, so we get the base 8. So for example, if I say a number 3, so we can say it, this is an octal number system, octal number. Similarly, if I say 7, this is an octal number system. If I say 56, this is an octal number system too. Now always remember that 56, you would say that it is greater than 8, but we are not counting it as 56, we count it as 5 and 6. So 5 and 6 are in the list of octal number system, which is 0, 1, 2, 3, 4, 5, 6, 7. So 5 and 6, you can see it here. Now if I say 81, now this is not an octal number system. This is not octal number system. Why? Because it consists of 8, and as I said earlier, 8 is not counted in the octal number system. So this is not an octal number system. Please make sure that you don't make a mistake like this. So the largest number in this case is 7, and the smallest number in octal number system is 8. So now let us, like other number systems as well, let us see in this case as well how we can represent octal number systems in the form of the powers of 8. Now let us see how we can represent any octal number system in the form of its powers of 8. Now for example, I am taking here in this case 50, no, let us take 63. Now 63 is indeed an octal number system because 6 comes in 0 to 7 and 3 comes in 0 to 7. Now how we can represent it, like in other examples as well, we saw that 3 into 8 raised to 0 plus 6 into 8 raised to 1. Now 0, 1, 2, 3, 4, 5, 6 for further digits. So 6 into 8 to the power 1 is 8, and 3 into 8 to the power 0 is nothing but 1. As I said earlier, anything raised to 0 is 1. Now 8 6 are 48 plus 3 into 1 is 3, which is nothing but 51. Now here also, to convert an octal number to decimal number, this method is applied. Why is this applied? We know that base is 8, so when we apply this method, means understanding the weights of the digit, it is indeed converted to decimal numbers. Let us see another example as well. This time let's take a bigger number, like 277. Okay, now we know that 2 into 8 raised to 2 plus 7 into 8 raised to 1 plus 7 into 8 raised to 0. Now it's your convenience. If you like to go from backside, means from 0, 1, 2, 3 like that, you can do it as like that as well. And if you want, if you're convenient to come from back, like for 3, 2, 1 and 0, that's also another way. So now we know that 2 into 8 raised to 2 is nothing but 64 plus 7 into 8 plus 7 into 1. We know that anything raised to 0 is 1. So 2 into 64 is 128 plus 8 7s are 56 plus 7 into 1 is 7. Now now when we add this, we get 128 plus 56 plus 7. So it is 191. Now this, as I said earlier, this converts a decimal number to binary number, sorry, a decimal octal number to binary number. Now this was about octal number system. Now let's go to the last number system, which is the hexadecimal number system. Now let us see about hexadecimal number systems. So hexadecimal number systems consist of total 15 numbers, not 15, total of 16 numbers. Now this is quite visible in the name itself, hexadecimal. Now what is deci? Deci means 10 and hexa means 6. So 6 plus 10 is nothing but 16. So there are total 16 numbers, and as usual, like any other number system, the numbers start from 0 and end at 15. Now there is a catch here, that 15 is not written as 15, as it would represent a decimal number. So we write it as F. Now F is nothing but 15. Okay, now how is this represented? Let's see. So we write 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now stop here itself. Now because, as I said earlier, decimal number, as it hexadecimal, the word itself for its decimal, so there will be definitely 10 numbers from 0 to 9, like a decimal number system. Now here's the difference, that further we will write A, B, C, D, E and F. Now what you will be shocked to see that where in numbers we are adding alphabets. Now here A represents 10, B represents 11, C represents 12, D represents 13, E represents 14 and F represents 15. Now this is how a hexadecimal number system works. Now for example, we can write any hexadecimal number system as 23 is an hexadecimal number system, and the base is 16. As I said, there are total numbers of 16, so base is 16. Another number system, another hexadecimal number is B3, which is nothing but 11, 3. B is nothing but 11 and this is 3. So B3 is again, and B is nothing but B3 is nothing but a hexadecimal number. It can be as long as you wish. A7, D, C, 6, like this. This is also an hexadecimal number. Now the largest number in this case is obvious, is 15, rather F, which is 15, and the smallest number is 0. Now any number system, the smallest number is 0 and the largest number will be the last number. Okay, now let us see how we can represent a hexadecimal number system in the powers of 16. Now let us see an example in this case. For example, let us take a simple example for understanding. 43. Okay, so 43 is an hexadecimal number, and now to represent it we can write 3 into 16 raised to 0. Like any other number system, we will write the base and then we'll take the powers of that base in a consecutive manner. 3 into 16 raised to 0 plus 4 into 16 raised to 1. That's nothing, it's not as hard as we think. 4 into 16 is nothing but 64, plus 3 into 16 raised to 0 is 3 into 1. So 16, 4 plus 3 is nothing but 67. This is also a way to convert a hexadecimal number to decimal number. Okay, now let us take a bit complicated example this time. B3. Okay, let's take an example of B3. B3 is nothing but 3 into 16 raised to 0 plus B, which is nothing but, let us take first B into 16 raised to 1. Now B is nothing but 11. B is 11, so 11 into 16 plus 3 into 1, which is nothing but 176 plus 3, which is 179. This is the value of B3 in hexadecimal number and is 179 in decimal number system. So I hope you have understood hexadecimal number system and also all the other number systems that exist. I will be bringing the conversion of these number systems, means like binary, decimal to binary, binary to decimal, all those interconversions. I hope while explaining the power system, I already explained a few conversions. Still, I will explain all the conversion systems in the next video. If you like this video, please like, share and subscribe to my channel. Thank you.